Okay, this one is just 7e to the 5x over 5 plus c. Not too bad. It's going to annoy me if they're here all night. And the last one, you're going to say 5x over ln of 5 plus c. Those are not absolute value signs, I'm sorry. If they put a negative right here, you just put a negative on top. Does that make sense, guys?
Yeah.
Excellent. You guys ready for your next round of problems?
Yeah.
Or round number 5. Okay, this is going to have some u subs and some parts. I'm not going to tell you which one's which, and you're going to have to figure it out.
Put the board up a little higher.
It doesn't go any higher.
It's just in the shadow, you can't really see it.
Better?
Yeah.
Okay. Oh, you guys are going to love this problem. Oh, yeah. That needs to be legible. Oh, no, that needs to be 12. Yep. Okay, try those. I hope that they're a little bit challenging, but not impossible. Let me roll cosine, sine. Hey guys. Tangent sine over cosine, u negative. Sine, cosine, tangent.
Don't cheat.
I think those are the only, are those the only trig ones you're supposed to remember? I think you're supposed to know secant, tangent, integral, secant, tangent, secant squared. Oh, I forgot my DUs. Sine, cosine, tangent, secant, tangent, secant squared, cotangent, cosecant. Cotangent. Did I mess up one of them? Did I make it impossible? That's possible. That's possible.
Yeah, number 6 is kind of down, so.
Number 6 is awesome. Okay, integral cosecant, cotangent is cosecant. How are you guys doing on number 5?
Good.
Number 7, is that negative 12x plus 8?
Yeah. I thought it was legible, but I can write bigger or How's that, Jimmy? Cool. Okay. First of all, who thinks it's U sub? Who thinks it's parts? Who doesn't know how to tell? Okay, how you tell the difference is U sub, let's write it down. This is important enough to write down. U sub, you're looking for a product or a quotient of two related functions. They're related by the derivative. Make sense? Parts has to be a product, and they're not related. Okay,
When you say related, can you expand on that, please?
I totally can expand on that. Is x squared the derivative of ln?
No.
Is the ln the derivative of x squared?
No.
So, they're not related.
Okay.
Is that okay? We're doing parts. I'm going to show you how I use the table. I use the table for parts on every single problem. This is called the forced stop. You only do this on ln's. So I've got my derivative column and my integral column. How many of you have seen the table before? How many of you have never seen the table before? Okay, the table is a way of doing parts, but it's usually faster. And in a little bit, you'll see why we like it so much. So the D column is the same thing as a U, and I is like dV. So, because I have a product, I need to pick which one I want to be in my derivative column and which one I want to be in my integral column. Do you guys know how to integrate ln of x? That must be the one that goes in our derivative column. You guys with me? Okay, you only do one derivative. You only go one level, and then you stop. This is only for the natural logs.
Wait, how did you know which one was where?
Can you integrate ln?
No.
Excellent. That means it has to go in the derivative column. Simple? Okay, so the derivative of ln is the derivative of the inside over the inside. Then we're going to integrate this. Everyone with me so far? Okay, then it has a plus, minus. We're going to multiply diagonally. When you multiply diagonal, you just write it down. It's not, you've already integrated that. And if you multiply horizontally, like we're going to multiply across, we have to integrate this. So far, so good? Is it okay if I bring it up a little bit, guys? I'm going to simplify this part. I'm going to cancel an x with this to make it x squared. So that I have 1/3 x cubed ln x minus 1/3 x cubed over 3 plus c, which simplifies to 1/3 x cubed ln of x minus 1/9 x cubed plus c. Is that okay? Josh, you with me? Rafa, you with me?
With you. Kind of.
Brent? You're just saying yeah. I can see that on your face.
Tell me again what happened to this negative 1 over x?
What happened to what?
The negative 1 over x. Did we not?
Okay. Yeah, we use that. So, right here we multiplied across. That's the negative. We have the 1 over x. We have x cubed over 3.
Okay.
We're going to cancel this x and this cube to make it x squared. Got it? Tell me what's up?
This trick only works with ln.
I use columns on everything. This is the trick on how to use columns and do ln. You with me?
We've never multiplied across the class. Is that just with the ln?
Just with ln.
Okay.
Next person? Who is, yeah?
When do you know when you can use the I? Let's see when you can.
If you're doing parts, you can always use it.
Really?
Yeah. Yep.
Do you,
Hello?
when using columns, I don't remember using the antiderivative or doing the antiderivative as a second term every time. Do we do that every time? I
We're
don't
taking the derivative of this side and we're integrating this side.
Right, but once you get down to 1/3 x cubed, ln x.
We're
minus
integrating.
Okay.
Are we okay, guys?
Just the last part, is that x cubed over 3 plus c in the very bottom? Should it be
Yeah.
x squared so she cancel out?
No, because we integrated then.
Okay, gotcha.
Are we okay so far?